So here we go, talking about combinations and permutations. Now, combinations and permutations are both way to order data, or talk about the order things can happen in. But the big difference is that when you're talking about permutation, order matters. So think about you're in the Olympics. It matters if you finish first, second, or third, right? Or fourth and you're the biggest loser, right? So order matters. Where you finish matters for whatever reason. Whereas combination, order does not matter. So that could be, 3 people are getting promotions and, it's the same promotion, it's the same raise in pay, blah, 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 blah. It doesn't matter if you're the first name picked or the third name picked because you're getting the same promotion. So the order does not matter. So that's the key. Order matters in permutations. It does not matter in combinations. So let's go ahead and look at a couple examples. 12 runners begin a race. Medals are awarded for the top 3 finishers, gold, silver, and bronze. How many ways can the 12 runners finish? So you're trying to talk about, orders of finishing. So you're talking about, you're ordering things. But the question that you have to ask yourself is, does the order matter? So when you're looking at this, gold, silver, and bronze, yeah, it matters. If I finish first, I get a gold medal. If I finish third, I get a bronze medal. If I finish 12th, I just get to say I played, right? So the order does matter, and therefore we are going to use the permutation. So when we think about permutation, generally we have the notation of the numbers on the side. So the number here, generally noted as n, is the total possibilities, which in this case is 12. So I'm going to have 12p3, because 3 is, sometimes this is an x, NPX, so we're talking about how many ways do we care. We only care about the top 3, right? Nobody ever talks about the Olympics and who finished 4th. You never hear that. You only see the top 3 finishers on the podium. That's who we care about. So hopefully you have a calculator. I have this done in a calculator, but there is a formula for this. So you can't actually just do, this is like 12 times 11 times 10, so you're talking about like a factorial starting with 12, but you only need 3 numbers because that's who you care about. So if I take 12 times 11 times 10, I get 1,320. So there's 1,320 ways that these 12 runners could finish, the top 3 finishers. Now, you might say that's not too bad in terms of showing this multiplication, but when you see the next problem, you're going to want to check out your calculator. So every calculator is a little bit different, but most calculators have a button that will allow you to type it in just like that, and it will calculate it for you. So you can always send me a message, and I'd be more than happy to help you with your calculator if that works. So, okay, next example. There are 15 players on the high school softball team. If there are 9 positions in the batting order, how many different distinct lineups are possible? Now, I threw this word distinct in there because I wanted it to be clear that the order matters. And if you're not familiar with softball or baseball, you might think it doesn't matter what order people bat in. But the order does matter, especially if you have a really good hitter, you want them to be in the front of the batting order so they get more at bats. Anyway, the order does matter. So again, we're talking about a permutation. Now, we have 15 total players to choose from, but only 9 that can be in the lineup. So think about the mathematics here. We're talking 15 times 14 times 13 times 12 times 11 times 10 times 9 times 3, 4, 5, 6, 7, 8, 9. So you have to multiply all those together. And remember, the more you have to put things into your calculator, the better chance you have of making a silly mistake. So if you can just type in 15p9, it's a whole lot better. And then check out this answer. And you might, punch this in and say, oh, that has to be wrong. No, that's absolutely right. So if you have 15 players on your team and you're trying to make a batting lineup of 9, you have 1,816,214,400 possible lineups. And this is why I used to coach softball, and I was like, this is why I was so stressed all the time, right? Because you have so many options. So it's crazy to think about how many different, because you can flip-flop players all over the place, and that's why there are so many. It matters because of the order. Last problem. At the end of a conference, 2 identical prizes are given away by drawing names out of a hat. If there are 75 people at the conference, how many winning duos could there be? So now you're looking at this. 75 people are there. They're going to pull out 2 names and give out identical prizes. I don't care if I'm the first name or the second name because I'm going to get the same prize, right? So in this case, we're talking about a combination. Your notation is the same. There are 75 total people and we're getting 2 prizes. Now in this case, since the order doesn't matter, we can take care of all of the overlap. So whether I'm first or second and Billy is first or second, doesn't matter. We're still the 2 getting the prizes. So that requires some division. So the formula starts the same way as the permutation formula, right? So we start with 75 and we need 2 of them. But now we're going to divide by 2 factorial, which in this case is just 2 times 1. So that gives me an answer of 2,775 possible winning duos. And again, your calculator should have a combination button where you can type those in and it will simply spit out your number.